Hello, self isolating sixth graders. Let's do chapter 3, lesson 3, which is going to be about igneous rocks. Igneous rocks is the first major category that we have of rocks, and our goal today is to understand what is an igneous rock and then how to start breaking that down into various subcategories of igneous rock. The definition that we will be working with is that igneous rock is rock formed when magma or lava solidifies. And that means that we are going to be starting off with liquid rock. And that's going to be the major distinction of igneous rock. Is the only way to get igneous rock is when liquid turns solid when it comes to rock material. Um, Remember from the previous lesson that we're going to be looking at four things to start breaking igneous rock into subcategories. The first is origin, where liquid turns to solid rock. That's going to be our first way to break down igneous rock. We will also look at texture, and origin in this case is going to have a significant impact on the texture or grain size of the rock. What the rock is made out of is going to be another way to help us break down the different types of igneous rock, and that is going to directly affect its color. So let's take a quick look at how we can do that to come up with four main possibilities for igneous rock. So igneous rock starts off in liquid form. If that liquid rock is underground, we call liquid rock underground magma. So magma is liquid rock underground. And that is going to form what's called intrusive igneous rock. And the way that I like to remember it is that you see the prefix in, and that means that magma is going to form rock inside the earth because it's underground. So intrusive rock comes from magma inside the earth. Liquid rock is above ground, and we can call that lava, and that's going to form extrusive igneous rock. So, really, the only difference between lava and magma is where it's at. Lava is above ground, magma is underground. Intrusive, inside the earth. Extrusive, lava has exited. You can almost see the word exit right there. Extrusive, exited the earth. It's above ground. So, in this picture, underground, we call it magma. Above ground, we call it lava. It's the same thing. Lava starts off as magma, but as soon as it comes up here and is above the ground, we call it lava. It's very difficult for lava to become magma because that would involve going back underground, and it just doesn't do that. But magma is underground, lava is above ground. Now, that's going to directly affect how quickly it turns to solid rock. Underground, magma is going to lose thermal energy and therefore turn to a solid much more slowly. The transfer of thermal energy from liquid rock to solid rock is going to be very, very slow. And this is going to give us very good mineral crystals that form because they have time to form. Lava is going to lose thermal energy way too quickly for any kind of nice mineral crystal formation. So lava loses thermal energy very, very quickly. It goes from a liquid to a solid very quickly, and that's going to affect what the rock looks like. You can tell that whether a igneous rock comes from magma or lava right away just by looking at the minerals. So whether it forms intrusively or extrusively is going to directly affect the texture of the rock. Um, Intrusive igneous rock, because it's inside the earth, loses thermal energy very, very slowly. And so mineral grains are well formed and very easy to see without any kind of magnification. Extrusive, the liquid rock has exited the earth. Is going to lose thermal energy very, very quickly, and the mineral grains are very difficult to see without magnification. So, Here we have two sets of igneous rocks. Some are intrusive, some are extrusive. You can tell just by looking at the size of the mineral grain. These four over here have mineral grains or a texture that you can see without any kind of magnification. These are made out of the same materials, but their crystals, individual mineral grains, are so small that it appears to be kind of just one color. So, very easy to see mineral grains, intrusive, this formed underground from magma, very, very poor mineral grains where it almost looks like one color. You would need magnification to see the individual mineral grains. This formed from lava, extrusive, liquid rock that has exited the earth. We're also going to take a very closer look at something called scoria or pumice. And you can easily tell that these rocks come from lava that cooled way too quickly. So here we have extrusive igneous rocks. These all come from lava that has exited the earth, and they lost thermal energy so quickly that they formed very, very poor or fine textures. Um, so this rock here, this rock here, this rock here, they have individual mineral crystals, but you need magnification to see it. This picture here is not a very good example of intrusive, or I'm sorry, extrusive igneous rock. You can almost see the individual mineral grains, but it's still formed extrusively. All right, pumice and scoria are really, really interesting. So let's take a closer look at that. All right. This rock came from lava and from a very, very explosive volcanic eruption. Imagine water that is boiling. Boiling water has a lot of bubbles. And imagine boiling water instantly freezing and trapping all of those air bubbles that were floating around or rising in the boiling water. Well, this is what happens with pumice and scoria. These were boiling hot liquid rock in a volcano. And then the volcano erupted and threw boiling liquid rock into the air. So that boiling liquid has a lot of air bubbles in it. As this liquid flew through the air, it solidified in mere seconds, often just a couple of seconds, and will actually freeze before it even hits the ground. So that means that all of those air bubbles kind of freeze in place. So this is liquid boiling rock that froze so quickly that it kind of trapped the air bubbles. So this is a very good sign that this came from lava extrusive igneous rock. And on top of that, there's very, very poor mineral grains because, well, they froze in seconds. They didn't have time to organize themselves and make nice crystals. Intrusive igneous rocks lose thermal energy so slowly that the mineral crystals have a lot of time to form, and you, without any kind of magnification, can see each individual mineral grain or crystal within these rocks. So just by looking, you can tell that these have very good texture, and so they are formed from intrusive magma. Back to what we were looking at yesterday. This is, or not yesterday, but Monday. Here we have the a good sign that this rock came from magma. This is an intrusive igneous rock. The fact that we can pick out individual minerals means that this cooled very, very slowly, and that means that it had to have come from magma. All right. The other way to kind of break down igneous rock is by mineral composition, which is going to affect color. There is a group of rock forming minerals called silicates. Silicates are minerals, compounds, that have both silicon and oxygen atoms. Now, there will be other minerals along for the ride. Um, but they at bare minimum have to have the elements silicon and oxygen in the compound molecule. If a mineral has both silicon and oxygen in it, then it falls under the category silicates. Igneous rocks that have a high amount of silicates um, are called granitic or felsic. They kind of go by both names. Some scientists use the word granitic, some scientists use the word felsic. So you're going to see both. If granitic or felsic igneous rocks have a high amount of silicates, that means that they have a low percentage of metals. Metals will make a igneous rock dark colored. Well, these have low metals, high silicates, and so these are going to be very light colored rocks. The opposite are going to be basaltic or mafic. Again, these two words mean the same thing. They're the opposite. They have a low amount of silicates, and silicates will make something light colored, and they will have a high percentage of metals, and metals make rocks dark colored. So basaltic or mafic rocks are very dark colored. So just by looking at the color, you can tell whether a igneous rock has a high or low amount of silicates and also a high or low amount of metals. Other minerals can add or change the overall color of a rock, but we'll try to keep it fairly simple. Okay, so here we have a nice little chart. Granitic or felsic tend to have less than 15% of your dark colored metals, your magnesiums, your irons, your metals that make things dark colored. Over here, we have basaltic or mafic rocks. And if more than 40% of the mineral composition is metals, that will make the overall appearance much darker. In the middle is another group, kind of like the in betweeners. These are called intermediates. Like you go to an intermediate school that's kind of like in the middle. And the fancy term is andesitic. We won't be focusing on these as much. We're going to be focusing on whether something is granitic or felsic or basaltic or mafic. All right, so this is going to give us six total possibilities, but we're only going to focus on the four corners. All right, intrusive and felsic means that it formed from magma. Okay, intrusive means it's from magma. And felsic means it's got a high amount of silicates, silicon, and oxygen. And that's going to make it very, very light colored. And because it's intrusive, we got very good mineral grains. The same mineral grains, the same silicates, if it forms from lava, extrusive, it formed too quickly to form these nice mineral grains. And so it kind of appears as one blurry color. And so we know that this is an extrusive felsic igneous rock. Granite and rhyolite are the exact same thing, but they formed in different locations. Granite formed underground and has a very good texture, coarse texture. Rhyolite is made out of the same materials but above ground, and so it looks different. It's got a very fine texture. The bottom left corner, here we have an intrusive mafic igneous rock or intrusive basaltic igneous rock. Good mineral texture, coarse texture, but also very dark colored because it's mafic. Low silicates, high metals. Gabbro and basalt would be the same rock, except they were formed in different locations, and so they have different textures. Basalt is extrusive, so it formed above ground from lava, but it's got a lot of metals in it, so we call it mafic. Here, again, is the intermediate or the andesitic, but we won't be focusing on these. But just know that they're kind of like the in-betweeners. All right, so for today's activity, I'm going to show you just pictures of rock, and your job is to classify them. Remember that if it is above ground, it's extrusive. If it formed below ground, it's intrusive. If it's light colored, we call it granitic or felsic. It's the same thing. If it's dark colored, it's got low silicates, high metals, and so it's basaltic or mafic. If it's coarse grained, that means it formed underground from magma and is intrusive. And if it is fine grained or has that bubbly, like frozen boiling water look, then we know that that is an extrusive igneous rock. Bye bye.